Hello everyone, welcome to this next video on complex analysis. In this video we shall take question from GATE 2004 exam and it is of 2 marks. The question is the number of zeros counting its multiplicities of the given polynomial. This polynomial is given to us having order 5, right? Inside the circle mod z is equal to 2 is which among these 4? So out of these 4 we have to tell how many zeros does this polynomial have inside this circle. Now this is important. So what is this region? This region is basically a circle with center at 0 and radius 2. So this is 0 and we have 2 over here, say minus 2 here and 2 here and minus 2 here. So that means our circle would be something like this. So on the circle, we will say inside this circle, they are saying inside this circle, how many zeros does this polynomial have? So one way is you can go for finding all the zeros. You can find all zeros of this polynomial. So obviously that procedure would be lengthy and in most of the cases you might end up finding 1 or 2 zeros and you may not be able to find all the zeros in the given amount of time. So what is the solution? The solution is given by this very beautiful theorem by that of Rauch, right? The this theorem says that if we are given two polynomials f of z and g of z which are both analytic inside and on a simple closed curve C, moreover, it is given that the modulus of any one of them is less than the other. So, the sum of these two polynomials that would be f of z plus g of z and the one having greater modulus, that means f of z in this case, these two, they have the same number of zeros inside C. So now let us look at how this theorem solves our problem. So for that we just deconstruct this polynomial. We are given this polynomial z raised to power 5 plus 3z cube plus z square plus 1. So we just deconstruct it into two polynomials. Say one is f of z, another is g of z. So let me take f of z to be z raised to power 5 and g of z to be this remaining portion. So it would be 3z cube plus z square plus 1. Now I can divide these two and take their modulus in order to obtain a relation between their modulus values. So if for this thing, I am checking whether f of z, modulus of this term, is greater than the modulus of this term or vice versa. So I am saying this thing modulus is greater than the modulus of f of z. So for that I am just substituting their values. So it would be z raised to power 5 and the value of g of z, that is 3z cube plus z square plus 1. So now I can use this inequality sign, right, and I can separate this modulus onto each term. So it would simply be 3 mod z cube plus mod z square plus 1. So now remember we have this region, so mod of z is equal to 2 over here. So we just simply substitute the value of mod of z is equal to 2 into this particular equation or relation. So it would be 2 to the power 5 and we would have 3 multiplied by 2 to the power 3 plus 2 to the power 2 plus 1. So when you simplify this thing, it turns out to be 32 divided by 29. So now this fraction is obviously greater than 1. So we end up by having this result that modulus of f of z is strictly greater than the modulus of g of z. So this is the relation that we obtain from here. So according to this theorem, now we have f of z the modulus of f of z greater than the modulus of g of z. So that means our polynomial, our original polynomial, which was the sum of these two polynomials, so that would have same number of roots same number of zeros as f of z. And what is f of z? F of z is z to the power 5. Therefore, obviously this polynomial would have 5 zeros inside the given circle mod z is equal to 2. Therefore, we can say our given polynomial has, so z raised to power 5 plus 3z cube plus z square plus 1, it has 5 zeros inside mod z is equal to 2. So this is our answer for this particular question. So obviously here option D is the correct option. Well, that is it for this video. Thank you for watching.